Welcome back, everyone. In this segment of the lesson, I'm going to remind you again of the definitions of volume and surface area. After that, we're going to dive into some more examples. Let's go to the first definition. So, just a reminder about surface area. We know that the total surface area of a polyhedron can be found by adding together the areas of each face of a polyhedron together. So I know that often a three-dimensional shape is made up of different shapes, or the exterior is made up of different shapes, but the surface area has got to do with the total area of the exterior of the particular shape. And by finding the total area of the exterior, that is my surface area. Let's go to the next slide. Cool. The volume of a three-dimensional shape refers to the capacity that the shape has. The volume of a three-dimensional shape is determined by first working out the area of the base. And once I have the area of the base of the object, I then multiply it by its perpendicular height. Please make sure that you have the perpendicular height for volume and not the slant height. Cool, guys, let's go to our first example. So, we have been given a spherical glass ball that has been tightly packed into a box. The box is in the shape of a cube. As shown in the picture, the radius of the ball is 6 centimeters. The second diagram shows the cross-section of the glass ball placed inside the box. We want to know what volume of the box remains after the glass ball is placed into it. So essentially, everyone, we have a glass ball that has been just squeezed into a box. And I want to know, with this glass ball in the box, what is the volume of the empty space left over? So the ball is sitting in the box, but I want to know how much space is actually left inside this box. So how are we going to do that? I'm going to let you guys think for a moment. So if we're working with volume, what I'm actually going to have to find out is what is the actual volume of the box and what is the volume of my actual ball, of the glass ball. Because then I can take the area of the box and subtract, sorry, not the area, I'm going to take the volume of the box and then I can subtract the volume of the ball. And that will let me know how much empty space is left. Let's go back to the board. So we are first going to look at the volume of the ball. And I know that the volume of the sphere is 4/3 pi r squared. And I actually know what my r is because I've been given it as 6 centimeters. So I'm going to fill that in. So it's going to be 4/3 pi times my radius squared. So let's pop this into my calculator. So it is 4/3 multiplied by pi multiplied by 6 squared, which is going to give me 150,8, because if I round to the second decimal place, that 796 will become 8. So 150,8, and we know it's centimeters cubed because it is in fact volume. Now we're going to work out the volume of the box, and the volume of the box will be determined by the dimensions of the box. But I can see that if the radius is 6 centimeters, that means that this entire length will be 12 centimeters. And as it is a cube, that means that each length will be 12 centimeters, 12 centimeters, 12 centimeters. And the volume of a box, we know, is taken by finding the area of the base and multiplying it by the height. But as it is a cube, each of these lengths is actually the same. So the volume of a box is length cubed. And then if I substitute in 12, it's going to be 12 cubed. So we're going to find that in our calculator. So 12 to the power of 3 is going to give me 1,728. So I'm going to carry this across so that I can actually determine how much of the box is empty. Cool, so we know that the volume of the space left over will be the volume of the entire box, and then we're going to subtract the volume of the ball. So the volume of the box is 1,728, and I'm going to subtract the volume of the ball, which is 150,8. So I'm going to plug this all into my calculator. So 1,728 minus 150,8, which is going to give me 1,577,2. And we know it's going to be centimeters cubed because it is a volume calculation. Great, guys. So after the break, we're going to be looking at some more measurement examples. See you soon.